How do you compare features of linear, exponential, and quadratic functions? Let's first review what those are. So, an exponential function is one that looks kind of like this. This is your parent function here, where f of x equals base, or your common ratio, to x as your exponent. A quadratic function is your parabola, f of x equals ax squared plus bx plus c. And a linear function is a straight line, f of x equals mx plus b. So these are kind of your parent functions, your basic ways of looking at these, except this is slope-intercept. It's not standard form in terms of what you call linear, but that's how I would write it. And that's how your graphs look, right? So it might be flipped around, translated, moved around, something like that, but generally that's it. So let's look at tables now. Now, when you're looking at tables, this is an exponential function. I'm going to tell you that, but I'm going to explain to you why, right? So when we look at tables, one way to do it is we make sure our x values are set up to kind of incrementally by 1. So we're increasing by 1 each time, so that's good. And then we look at our y values and we find the first difference, which is basically I do 8 minus 4 is 4. 16 minus 8 is 8. 32 minus 16 is 16. 64 minus 32 is 32, right? 128 minus 64 is 64. So I find the first difference. If the first differences are all the same, it's a linear function. 4, 8, these are not all the same. They're different. So now I find the second difference. So this is called the first difference. Then I find the second difference between these numbers. 8 minus 4 is 4. 16 minus 8 is 8. 32 minus 16 is 16. 64 minus 32 is 32. If these are all the same, it is quadratic. So I see that these are not all the same. So I'm not linear, I'm not quadratic. What you can do is look for a common ratio. So basically I'm saying 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So I do have that common ratio of times 2, which means I'm probably looking at something like 2 to the x. Some kind of function similar to that where you're looking at, you're multiplying by 2 with a base of 2 there. And this is exponential. It's not linear, not quadratic, that's exponential. Let's look at a different example. In this example, we have a quadratic, so our second differences should be all the same. Our x's are set up so they're incrementally by 1. So we go, the first one, our first difference is 0 minus 3, which is negative 3. Negative 1 minus 0, which is negative 1. 0 minus negative 1, which is going to be positive 1. 0 minus negative 1 is plus 1. Okay. 3 minus 0 is 3. 8 minus 3 is 5. Let's figure out the differences between here. Negative 1 minus negative 3. So that's going to be plus 3. Negative 1 plus 3 would be positive 2. 1 minus negative 1 would be 1 plus 1, which is positive 2. 3 minus 1 is 2. 5 minus 3 is 2. You can see my second difference are all the same, making this quadratic because the second differences are all the same. Here's another one that we kind of have to figure out. Let's look at this one. All right, so 2, negative 1, so these are all in order. Let's figure out our first difference. 12 minus 15 is negative 3. 9 minus 12 is negative 3. Okay, so these look to be the same. 6 minus 9, negative 3. 3 minus 6, negative 3. So my first difference is all negative 3. I don't need to figure out the second difference in this case because it's going to be 0. 3, negative 3, it's all going to be 0, so there's no point in doing it. We know that we're dealing with what's called a linear function here, and that's the example here. So a key thing to remember too is their graphs, what their functions look like. You're like x squared is quadratic, x with no exponent is linear. B, or some number to the x, is exponential. Your graphs look different as well. You have your parabola on quadratics, a straight line for linear, and exponential is curved as well, but just has that different shape compared to quadratic. How do you compare features of linear, exponential, and quadratic functions?